In this problem, we're giving the starting molecule and we're giving the final molecule in a sequence of reaction, and we need to explain how we got there using this starting molecule and the reagents that we have. So I have a list of the things that we will be using for that. Reaction 1, we're going to be using ethylene glycol, acidic conditions. In step 2, I'm going to be using a series of things here. I'm using triphenylphosphine followed by, let's do green. I'm going to do M-butyl lithium, so butyl lithium, and then I'm going to add formaldehyde. And that is a sequence that I'm going to do. I need to do all of those reactions. I'm going to continue here. Reaction number 5, I have acidic conditions. Then I'm going to do HBr and peroxide. Then I'm going to number 7. I'm going to be using sodium boron hydride in methanol. And reaction 8, I'm going to be using sodium hydride. So let's get to do all of that. Now, first step, what are we doing here? Here, this reaction is to form a cyclic acetal. I'm going to make it right there. So reaction 1, and simply what I'm doing here is saying number 1, the first reaction. The product of reaction number 1 is the cyclic acetal here. This is typically used to protect carbonyls. So that's the first product. Okay, so now I'm using triphenylphosphine. So in that step, number 2, triphenylphosphine, I'm going to do an SN2 over here. So next, I'm going to have, still keeping this part, but here I'm going to have phenylphosphine, and this has a positive charge. So far, this is what we have. Butyl lithium is a very strong base, so this is plus the counter ion, this negative. Essentially, what this does is remove one hydrogen here to form an Aldehyde. These 2 steps is to make the Wittig reagent. This is, I'm going to write that down. This is making a Wittig and forming an Aldehyde here. So by using butyl lithium, this was reaction 2. In reaction 3, I'm going to remove one hydrogen here. So I'm going to have this negative. Still keep having, remember, acetals are stable under basic conditions, so that will stay right there. Here you have your Aldehyde, and here you can write your resonance structure, forming the double bond carbon phosphorus, pH3. And then I see in reaction, all I'm doing again, the 2N3, and yeah, 2N3, yes, we're forming that. Those 2, making the Wittig. Step 4, I am doing, I want to refresh you right over there. Still have many more reactions to do. So I'm going to do it over here. So I'm going to do reaction 4. This is formaldehyde. And what we're doing is now the Wittig is inserted here. So doing my acetone, same. And now I have, this is, you're simply adding one more carbon to the chain to your Wittig. This is inserted, all of these inserted here. So that that way I'm making the that alkene. So in this way, I'm going to, this is 4, right? Reaction 4. So next, what am I doing? Reaction 5. That is the hydrolysis of the acetal. So I'm going to go to the carbonyl now. Back to this. Next, I'm doing HBr with peroxide. So HBr with peroxide, that is, the hydrohalogenation is happening anti-Markovnikov. So what that means is that I'm putting the H here and the bromine there. So when I do reaction 6, which is the anti-Markovnikov, the product I will end up having is, I will have a bromine right at the end. So up to that spot, now I have hydride, sodium boron hydride. What this reagent is doing is the reduction of the aldehyde, and it reduces that to an alcohol. So now I am reducing this. Here we said this is 6. Now I'm doing 7, and I'm drawing the product of reaction 7. That's bromine, and I have 1, 2, 3, 1, 2, 3, and then this is an OH. Now it is an alcohol. Next step, it says sodium hydride. So that sodium hydride, we can, well, the most acidic hydrogen, what is the most acidic hydrogen in this molecule? Is the alcohol. So let me change the arrow and make it lower since I'm trying to fit everything on the screen. So I'm gonna do now this, removing the most acidic hydrogen is making this. And now what I'm doing is an internal SN2. So I'm gonna do this in the next step. And now I'm making a cyclic structure that will have 1, 2, 3, 4, and 5 with the O, and that is what I have here in the final. So after that attack, I'm gonna get the final molecule. So I'm gonna do like a little star here, this, go here, which is what I wanted to do. So with this sequence, we have explained how we, using all these reactions, have obtained that compound, starting from the beta bromo 1, 2, 3 propanol, or 1, 2, 3 brom. All right, so I hope that this give you an idea of how to complete a sequence of reaction and predict correctly, be able to predict that product.